Calculus. Myself, I am S.Selvarethna, S.Selvarethna, Assistant Professor, Department of Mathematics, BSN College of Engineering and Technology. Differential Calculus. Differential Calculus, the differentiating and calculus part. Differential Calculus. Calculus is divided into two parts, integrals and differential. Integrate part and differentiate part, two parts there. First one is differential part, second one is integral part. Integrate values are partial integration, normal integration, different two types. Differentiation, many types, quotient type, partial, product type, many types differentials. Integral calculus studies the area under the curve, mentioned area, find the value of the integral. Next one, differential calculus deals with the study of rates and of change of functions and how these functions behave when there are very small changes in their independent variables, small changes, dependent variables apart from independent variables. Differentiation, the format is x slope, y slope, change in x, change in y divided by change in x, slope equal to change in y by change in x, dy by dx, denoted as symbol is dy by dx. Y with respect to x, differentiate with respect to x, differentiate definition. It is primarily concerned with the concept of a derivative which represents the rate of change of a function with respect to a variable. First one is mentioned function f of x value, then apply for the integrate functions, differentiate function, then we get the value. Functions represent only y values. Another one is the differentiate part is x. Y with respect to x, differentiate with respect to x, y value given with respect to x value, differentiation type. Third one is differential calculus, general ways. In mathematical, differential calculus is a subfield of calculus. So calculus or subfield, subfield of calculus that studies the rate at which quantities change. The primary objects of study in differential calculus are the derivative of a function, related notions such as a differential. Differential calculus are the derivative of a function, derivative of a y value with respect to x, related notion as a differential, and their applications. The derivative of a function at the chosen input equals the instantaneous rate of change of the function at the input. The process of finding the derivative is called differentiation. Geometrically, the derivative at a point is the slope of the tangent line value differentiate with respect to y or x to the graph of the function at the point provided that the derivative exists and is defined at the point value is given, slope value differentiate with respect to y or x. For a real valued function of a single real variable, the derivative of function at a point generally determines the best in linear approximation to the function at that time. Time information in linear approximations. Function. Last one is differential calculus is one of the two traditional divisions of calculus. The other being integral calculus, the study of accumulation of or area beneath a curve. Mentioned area, calculate the integral calculus format, apply the integral calculus format integration, then we get the result. Today we seeing the topic differential calculus. Differential calculus, many types there, many topics. First one is functions, second one is limit of function, third one is limit laws, The fourth one is continuity. Fifth one is intermediate value theorem. Sixth one is derivatives. Seventh one is differentiation rules. First one is function. First one is function. A function f is a rule that assign to each element x in a set D. Each element in a set D. D, x belongs to D concept. X belongs to D. The set value is D. D is the domain value. Domain set value element is x. Exactly one element called f of x in a set E. Another one element is f of x. Function is codomain value E. Another set E. But D is the domain of the function f. E is the codomain of f. The range of f equal to f of x such that x belongs to D. F of x is the function. Get the result, and x belongs to D, domain value. X belongs to the domain value. Containing E. Total variable containing E set. E set is contain of the function. Total function containing E set. Here x is the independent variable and f of x is the dependent variable. Independent variable is x. F of x function of f of x. Function of x is a dependent variable. Example, function of example, real value to real value. F from R to R, real to real, R to R, comma, f of x equal to x power 3. X power 3 is our small function. Real value 1 or 2, 3, 4, 5 real values. Apply the real values and get the result. Functions get the result in codomain value. Domain value, apply the domain value, then we get the codomain value. So f of x equal to x, first example. Second one, R to R, f of x equal to 3x minus 1. Real value, so 1 or 2, 3 minus 1, answer is 2. 2 also real value. But put the value in domain value, we get the value codomain value. This is the function. Second one, next function. Another one is symmetry function. Symmetry function, if the function f satisfies two concepts, minus x plus x concept. First one is minus x plus 1. F of minus x equal to f of x. F of negative value, some negative value, minus 1 or minus 2, minus 3, some negative value. Answer is given for the positive value. For it is a symmetric form of the first step. F of minus x equal to f of x. For every number x in its domain, then f is called a even function. We put a negative value, then we get a positive value. This is called a even function. First one. Second one is we put a negative minus of f of minus x equal to f of x. Minus value, we put a negative value, we get a minus of positive value. My negative values for every number in x in its domain, then f is called a odd function. Minus of value get the result, so f is a odd function. We get the value as a even real value or plus value, so we get the result as even function. F of minus x equal to f of x is the even function. F of minus x equal to minus f of x is the odd function. Then next one, example of the odd and even function. First one, odd function. First example, odd function. F of x equal to some values. F of x equal to some value given, x square divided by x power 4 plus 1. We put a value of x equal to minus x. We put a value x equal to minus x. So minus x the whole square, minus x square divided by minus x the whole power 4 plus 1. Minus of x, minus into minus plus x square, value x square divided by x power 4. 4 is a even number, so minus into minus into minus into minus also plus. So x will be plus 1. We get the answer is same answer, f of x equal to f of x. F of minus x equal to f of x. So it is a even function. We get the value is written again f of x value. So it is a even function. Next one, even function. Next example, even function. F of x equal to x modulus x. Now x replaced to minus x. We put a value of x equal to minus x. F of minus x equal to minus x. Modulus of minus x equal to, modulus of minus x is a plus value. Modulus value minus value is also a plus value. So modulus x is a plus modulus x. Minus x modulus x, minus into, answer is minus into x into modulus x value f of x minus f of x. The next get a value f of x equal to x square, f of x equal to x square, x greater than or equal to 0, f of x equal to minus x square, x less than 0, x value equal to 0 or greater than 0, 0, 1, 2, 3, 4 values. First one. Second one, less than 0, less than 0, negative values. First one is positive value, second one is negative value. Negative value will reach answer minus x square. Positive value which will reach answer positive value. Okay. Then f of minus x equal to minus x square, x greater than or equal to 0, x square, x less than 0. F of x is an odd function. F of x is an odd function. Even function. F of x is an even function. F of x is an even function. The next one, definition of composition of function. Another one function, first one normal function, second one symmetric function, third one composition of function. Give two functions f and g, two functions, take two functions f and g. The composite of function, composite denoted as dot value, 0, 0, 0 composite. The composite function f composite g, f composite g, composition with respect to f to g, f composite g, also called composition of two function f and g. F composite g, also called composition of two functions f and g, is defined as f composite g of x equal to f of g of x. Composite apply for this f of g of x. Note, it is possible to take composition of three or more functions. 3 or more functions. The examples, if f of x equal to root x and g of x equal to root of 3 minus x, find each of the following function and its domain. Following values, calculate value. First one is A, f composite g, B, g composite f, C, f composite f, D, g composite g, f to g, g to f, f to f, g to g. First one, A, f composite g of x. Definition, f of g of x equal to f of g of x value root of 3 minus x, f of root of 3 minus x. Next one, f of root of 3 minus x, f of x value root x, f of x value root x value root x value 3 minus x. So integral, so equal to root of, another one, root of 3 minus x. Root of, first root is a function root, second one x value root of 3 minus x, function f of x value root x, root first apply for the root, next x value root of 3 minus x, root into root 3 minus x, for square root value. So two roots there, two roots, 2 into 2, 4 root, 4 into root of 3 minus x, and the domain d equal to x in x, 3 minus x greater than equal to 0. Next one, g of x of x. The g of f of x conversion definition, root of 3 minus f of x value. First one is f of x value root x. Second, g of x, g of root x value, g of x value root of 3 minus x value root x, so root of 3 minus root x. So domain d equal to x, 3 minus root x greater than or equal to 0, positive values. Here 3 minus root x greater than or equal to 0, 3 greater than or equal to root x, 9 greater than or equal to x, square root. Take square on both sides, 3 square, root x the whole square, root cancel, x, 3 square 9, 9 greater than or equal to x. D, so domain equal to x colon 0 less than or equal to x less than or equal to 9. Limit is 0 to 9. Third one, f composite f, same number, same function, f to f. So written as composite definition, f of x. F of x value root x, another f of x value root x, root of root x. Root value 1 by 4. So root of 1 by 4 cancel to the root 4, 1 by 4. Domain d equal to 0 to infinity. Open close to open interval. Next one, d, same interval, g to g. G composite g of x equal to g of x equal to g of x value root of 3 minus x, again g of x value root of 3 minus x value root of 3 minus x, so root of 3 minus 3, root of 3 minus x. Domain d equal to x, 3 minus root of 3 minus x greater than or equal to 0 also, 3 root of 3 minus x greater than or equal to 0, 3 greater than or equal to x. Here 3 minus root of 3 minus x, 3 square 9, 9 greater than or equal to 3 minus x greater than or equal to 3 minus 9. So answer is minus 6, x greater than or equal to minus 6, negative minus 6, minus 6, minus 6, and minus 6, next value, greatest value, 6 minus 5 minus 4 minus 3 minus 2 minus 1 0 1 2 3 4 5 6 extra infinity times, x greater than or equal to minus 6. So we get a domain d equal to x minus 6 less than or equal to x less than or equal to 3. The next one, limit of a function. Second topic, limit of a function. First one is a function, symmetric function and composite of function. Next topic is limit of a function. Limit apply to the limit in function values, we get a positive value. Suppose f of x is defined when x is near the number a, then we write limit x tends to a, f of x equal to L. F of x is a function, limit values x to x approach to a, x value replace to a, we get the result is some constant value equal to capital, and we say that the limit of f of x as x approaches a equals L. This is the limit function. A function applied to the x replace to some value, we get a constant value as 0. One-sided limits. Limits two sides limits, one side and right side, left side and right side. One-sided limits, two sides are there. First one is left side, second one is right side. First one is left side, left hand limit. Left side values are all negative values. Left side values are all negative values. We write limit x approaches to a negative f of x equal to L, and we say that the limit of f of x a as x approaches a equals L from the left. If we can make the values of f of x arbitrarily holds to L, by taking x to be sufficiently close to a and x less than a. Value, negative value apply to negative value. F of x replaced to negative value, we get a result is called a left hand side limit. Second one, right hand limit. We write limit x tends to a plus values. Right side values 0 to infinity values. F of x equal to L. This also says that the limit of f of x as x approaches a equals L from the right if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a and x greater than a. The limits is left and right limit add to the total values, two-sided limit are exist. Limit left equal to right, then it is a limit function, original limit function. Left equal to right, two values are equal, so it is a limit function. Left limit and right limit equal to same. Limit extends to a, f of x equal to extends to a first and second. F extends to f of x is a original value, two-sided value, equal to two-sided value is also a minus L, capital L. Right side value a plus value equal to left side value negative value also L. So right hand limit and left hand limit are same. The limit is exist. Right hand limit equal to left hand limit equal to L. So limit is exist. The function is exist. Next one, some examples. Find the first one. Limit extends to 0 sin 5x divided by 2x. First one. Second one, limit extends to 0 x got x. Third one, limit extends to infinity x sin 1 by x. Solution. First one, limit extends to 0 sin 5x by 2x equal to limit extends to 0. First one is limit x value is 0. So that apply, answer is 0. So we take a simplification format. 5 add to delete, add to multiply. 5 multiply and dividing. 5 by multiply and dividing. 5 value 5. So 5 numerator multiply, denominator value divide value. 5 into sin 5x divided by 2 into 5x. 5 by 2 is a constant value. Limit of x tends to 0 sin 5x by 5x equal to 1. Limit of x tends to 0 sin theta divided by limit general result is limit theta tends to 0 sin theta by theta equal to 1. So apply for this result. Limit x tends to 0 sin 5x by 5x equal to 1. So answer is 5 by 2. Second one, limit x tends to 0 x got x. Got x value replaced to cos by sin. Got x equal to cos by sin. Limit x tends to 0 x into cos by sin. Limit x tends to 0 cos x divided by sin x by x value. We put on the denominator value. So x sin x divided by x. We write the denominator value. So cos x divided by sin x by x. Normal condition, limit x tends to 0 sin x by x. Previous some apply for this some result. So, limit x tends to 0 sin x by x equal to 1. Cos x value also cos 0 value is also 1. 1 by 1 answer is 1. Second one. Third one, limit x tends to infinity x sin 1 by x. Limit x tends to infinity sin 1 by x divided by 1 by x. X is replaced to denominator value x 1 by x. So sin x tends to infinity, sin x by x equal to 1. Answer is 1. This is a limit function. Examples. Second one limit function, plus or minus, right limit and left limit. Determine limit x tends to 3 plus x plus 2 divided by x minus 3, comma limit x tends to 3 minus negative value x plus 2 divided by x minus 3. If x is close to 3 but larger than 3, then denominator x minus 3 is a small positive number, and x plus 2 is close to 5. So close to 5, which is 3 plus 2, so 5, close to 5. So the quotient x plus 2 divided by x minus 3 is large number. Limit x tends to 3 plus x plus 2 divided by x minus 3 equal to infinity, plus values. Numerator part also plus, denominator part also plus. So plus infinity values. And second one, if x is close to 3 but smaller than 3. F is close to 3 but smaller than 3, negative value, then denominator x minus 3 is a small negative number and x plus 2 is close to 5. So the quotient x plus 2 divided by x minus 3 is numerically large negative number. Negative values are included. So answer is minus infinity. First one is large number, large plus values and negative values. Second one is negative value. Next one, limit laws. Limit apply for the some laws apply for the questions, and differential calculus for subjects. Suppose that c is a constant. Value. C is some constant value. I get it. And the limit x tends to a f of x and limit x tends to a g of x exist. Two functions are exist, limit functions. First one is limit x tends to a f of x and limit x tends to a g of x. Second one exist. So then we get the laws. Limit laws are two functions. Limit x tends to a f of x. First one is plus or minus g of x. First function operation is plus or minus. Limit of x tends to a f of x plus or minus g of x equal to individual values applied to the limits. Limit x tends to a f of x plus or minus limit x tends to a g of x. Second one, limit x tends to a some constant value into function c into f of x equal to c into limit x tends to a f of x. C is a constant, so we write it first write a constant value, then apply for the limit function, then apply for the limit values in function. Third one, limit x tends to a f of x into g of x. Into concept, apply to the limits in individual value. First function is f of x, second function is g of x. Limit x tends to a f of x into limit x tends to a g of x. Fourth law, limit x tends to a divide concept. First one plus or minus, second one constant value, third one multiply, fourth one divide. F of x divided by g of x equal to limit x tends to a f of x divided by limit x tends to a g of x. The denominator value limit x tends to a g of x must not equal to 0. Fifth one, limit x tends to a f of x power n. Limit x tends to a f of x power whole power n. N is a positive number. Next one, sixth one, limit x tends to a constant value. So we get a constant value equal to c. Seventh one, limit x tends to a x. X replaced to a, answer is a. Eighth one, limit x tends to a, x power n. X replaces to a power n. N is a positive number. Next one, limit x tends to a, n root x equal to n root a. N is a positive integer. Positive integer. Tenth one, limit x tends to a, nth root of f of x, nth root of limit x tends to f of x. N is a positive integer. N is even. Assume limit value also greater than or equal to 0 values. Even value also 0. Next 0 to infinity values. Next one, properties. Limit properties. First one is direct substitution property. If f is a polynomial function or rational function, polynomial function or divide concept, point concept, rational function, and a is in the domain of f, then limit x tends to a, f of x equal to f of a. We put this type of definitions. Second property, f of x less than or equal to g of x. When x is near a, except possibly at a, except, and the limit of f and g both exist as x approaches a, then limit x tends to a, f of x less than or equal to limit x tends to a, g of x. Condition less than or equal to condition is center format, function to function. For limit x tends to a, f of x less than or equal to limit x tends to a, g of x. Next one, third topic, continuity. Limit class, third topic. Fourth one is continuity. Continuity also same as a limit function, and limit exists, and which also continuous also exists. The function f is said to be continuous at a number a if limit exists, some constant value exists. This is a continuity. Limit function existed some constant value. Limit x tends to a, f of x equal to f of a. Remark a function f continuous at an interval if it is continuous at every point of it. Every point. Limit x plus values. Right limit continuous from the right. Left limit continuous from the left. Must continuous concept is that. Continuity definition. Second, next one, example, continuity. Explain why the function is discontinuous at x equal to 3. Why the function is discontinuous? X equal to 3 is a discontinuous function. Why is the question? If x equal to 3, 2x square minus 5x minus 3 divided by x minus 3. If x not equal to 0, and there is 6x equal to 0. Solution, limit x tends to 3, 2x square minus 5x minus 3 divided by x minus 3. Limit x tends to 3, 2x square minus 5x minus 5x is replaced to minus 6x plus x minus 3 divided by x minus 3. So root is 2x plus 1 into x minus 3. X minus 3 is cancel. X minus 3 and x minus 3 is cancel. And remaining 2x plus 1, x replaced to 3, 2 into 3 is 6, 6 plus 1, 7. Answer is 7. But f of 3 equal to 6. F of 3 equal to 6. Therefore, f is not a continuous at x equal to 3. X equal to 3 value is a not continuous function of f of x. So, answer is given the function answer is 7. But f of 3 is a 6. So, it is a not continuous function. This is a discontinuous function at x equal to 3. Second one, check the continuity of the function f of x equal to 1 minus cos power 3x divided by tan square x. If x not equal to 0, 3 by 2 if x equal to 0. At x equal to 0. X equal to 0 values. First one, x minus cos power 3x. A cube minus b cube formula. A value 1, b value cos x. A cube minus b cube formula, a minus b into a square plus b square plus a 1 minus cos x into 1 plus cos square x plus cos x divided by Divided value tan square x replaced to sin by cos. So cos x is replaced to numerator part. Replaced to write the numerator part. So cos square x divided by sin square x. Sin square x is sin square x equal to 1 minus cos square x. 1 plus cos square x. Sin square x formula 1 plus cos square x. A square plus a square plus a plus a square minus b square equal to a plus b, a minus b concept. 1 minus cos x into 1 plus sin cos x. 1 minus cos x, 1 minus cos x cancel. Remaining values 1 plus cos square x plus cos x into cos square x. Cos square x plus cos 4x plus cos x divided by 1 minus cos x. X replaced to 0. X replaced to 0. Answer is cos, first one cos square x, cos square x. Cos 0 value is 1. Cos 0 value is 1. 1 plus 1 plus 1. Answer 3. Numerator value. Denominator value 1 plus cos x. Cos x x equal to 0. So 1 plus 1 2. 3 by 2. Answer is 3 by 2. X equal to 0. Answer is 3 by 2. Same answer. X equal to 0. Answer is 3 by 2. So if at x equal to 0 is the given function. So it is continuous function. Answer also correct values exist. So it is a continuous function, not discontinuous function. Previous problem, given condition 6, get the result is 7. So it is a not continuous. Given condition is 3 by 2, get the result also 3 by 2. So it is a continuous function. The next, find the number at which f is discontinuous, at which f is continuous from left and from right. Left and right. 2 minus x. 2 minus x is a negative value, minus 1. Minus 1, minus 1, minus 2, negative values. So it is also negative value. Negative diagram is negative value. A y equal to 2 minus x. Second one, minus 1 to 1, center value. Y equal to x line, center value, minus 1 to 1. Third one, x minus 1 the whole square. S is a greater than or equal to 1. So plus value. So right side value. Graph is the right side value. Left and right continuous part. Okay. F is continuous from left at x equal to minus 1. Reach the value minus values. X equal to 1 plus value. X equal to minus 1. Not continuous. So not equal. Not left value positive value. Not continuous. So answer is not. Derivative of a function. Next one is derivative of a function. The derivative of a function denoted by f dash of x and f dash of x. Derivative denoted as f dash of x. Definition is f dash of x equal to limit h tends to 0. H is some positive value. H tends to 0. F of x minus x plus h minus f of x divided by h. H is a many times which is a unit value, 1 unit values are there. Hence the derivative of a function factor number number a denoted by f dash of a is written as f dash of a equal to limit h tends to a f of a plus h minus f of a divided by h. First one is general format f dash of x. Second one, some values are, some letters are different. So second one is x replaced to a. Formula is changed to a, x to a. Remark, if x is differentiable at a, then f is continuous at a. F is differentiable at a, and f is also continuous at a. Continuous, also continuous and differentiable. Dash of a equal to limit x tends to a, f of x minus f of a divided by x minus a, and f of x apply to the limit numerator and denominator part individual term. Limit x tends to a f of x minus f of a divided by limit x tends to a f of a, limit x tends to a f of x minus f of a equal to limit x tends to a f of a into some constant f dash of a. So equal to 0, some constant value. So answer is f of limit x tends to a f of x equal to f of a. Limit is applied only for the x value. F of a is a constant value, so it is an neglect them. Limit x tends to f of x into minus f of a. So minus replace to plus in right side value. So answer is limit x tends to a f of x equal to f of a. Continuous limit function and continuous function also exist. So it is a derivative concept. Find f dash of x using the definition of derivative. Simple example, f of x equal to x square plus x plus 1. Solution, f of x, we have f dash of x equal to limit x tends to 0 f of x plus h minus f of x divided by h. F of x value x square plus x plus 1. F of x plus h value also x replaced to x plus h. X plus h whole square plus x plus h plus 1 minus f of x value given condition x square plus x plus 1 divided by h divided by h. So x a plus b the whole square a square plus b square plus 2xh plus x plus h plus 1. So x square minus x square cancel, minus x plus x cancel, x1 minus 1 plus 1 cancel. Remaining value h square plus 2hx plus h. H is a common to 3 times. So h common to 3 times. Outside to return. H into h plus 2x plus 1 divided by h cancel. Remaining h plus 2x plus 1. X replaced to h replaced to 0. So answer is 2x plus 1. Second example, root x. This is also same format. F of x value is root x. F of x plus h value is root of x plus h. Root x plus h numerator value is highest. So conjugate value, multiply the conjugate value. Numerator root of x plus h minus root x. So it plus value root of x plus h plus root x divided by root of x plus h plus root x. H divided by x plus root of x plus h, root of x plus h. A plus b a minus b a square plus b square. X plus h, x plus h, a plus b a square plus b square, a square root cancel. So x plus h plus x plus x, a square minus x, x plus b, x plus h minus x versus cancel. Remaining numerator value h, denominator value h into root of x plus h plus root x. Then apply h equal to 0, h cancel. Remaining 1 divided by x plus 0 root x plus root x, 2 root x. Answer is 1 divided by 2 root x. Third one also same format. F of x equal to 3x square plus 2x plus 1. So same concept. Apply to the x plus h format. Apply for this. Next, simplifying. Last final answer is x plus 2. F double dash value. First one is f dash value. Second one double dash value. But double dash value derivative values 6 into x plus h plus 2 minus 6x minus 2. F dash of x value, f dash of double x value, f dash of x value. Answer is again 6. F dash of x 6 by x plus 2, f double dash 6. Next one, derivatives of polynomial values. X derivative constant value apply for the answer is 1 constant value. X power n differentiate part n into x power n minus 1 log a power x 1 by x log a e ln e. A power x is ln a. F dash of x e power x is replaced to e power x. differentiation. Another one is product rule and quotient rule, product rule and quotient rule, and properties, plus or minus properties. Plus or minus property apply individual values apply for that. Next one, product rule, quotient rule, chain rule, tangent values. See, thank you. Last one is differentiating part. Derivative concept is sin x. Find sin x. We get the result is cos x. Cos x, same formula. Apply for this cos a plus b formula. Then cancel. Normal values apply for that. As final values exist. So thank you.